Hello and welcome. In this video, we'll be looking at solving exponents. Now, I do want to clarify that if you were looking for a video that has negative exponents, this is not the correct video for you. In this video, we'll be looking at positive exponents with rational number bases. So if you are interested in what to do if you have a negative base, a fraction or decimal base in your exponent, please continue to watch. So the first thing we want to do is define an exponent. What is an exponent? And an exponent is a way to show repeated multiplication. So it's a shorthand method when we want to show the same number multiplied repeatedly. And there are two parts of an exponent, the base and the exponent itself. The base is the number being multiplied, and the exponent is how many times we're multiplying it. So, for example, if we had 2 to the third power, our 2 would be the base and our 3 would be the exponent. So the 2 is what we're multiplying and the 3 tells us how many times. So we'll be multiplying 2 times itself 3 times. Okay, so that is how an exponent is used and how we can expand it out. So let's start by looking at a few examples of positive numbers with positive bases, positive exponents. So our first one is 3 to the second power. That means 3 times itself 2 times. And 3 times 3 gives us 9. We have 2 to the fourth power. That's 2 times itself 4 times, according to our exponent. Okay, so 2 times 2 is 4. 2 times 2 is 4. 4 times 4 gives us 16. Now, our last example of positive bases and positive exponents is 6 to the fifth power. So that's 6 times 6 times 6 times a 6 times a 6. So 6 times itself 5 times. So we know 6 times 6 is 36. 6 times 6 is 36. And we bring down our last 6. Now we're doing 36 times 36. And I went ahead and worked this out prior. That's 1,296 times 6. Okay, so our final answer for 6 to the fifth power is 7,776. So we can see that because it's repeated multiplications, our answers grow very quickly, which is where the word exponential growth comes from. You see a very rapid growth in numbers as you multiply together. So now let's look what happens when we have negative or integer bases. Now you can see I've written things a couple of different ways because there is some difference between the second problem and the third problem, but we'll discuss that in a minute. Okay, so we have 5 to the second power, but now we have a negative. So we have negative 5 to the second power. So that means negative 5 times negative 5. Okay, so 5 times 5 is 25. A negative times a negative makes a positive, so I have a positive answer. My next one is the same thing. The negative is inside the parentheses with the 4, and it's 4 to the third. So I have negative 4 times negative 4 times negative 4. Now, I don't always, but you can put each of these negatives inside of parentheses if it helps you keep your work more organized. So a negative 4 times a negative 4. I know 4 times 4 is 16. A negative times a negative makes a positive. Bring down our remaining negative 4. So we have 16 times negative 4. I know 16 times 4 is 64. I have a positive number times a negative number, and that makes a negative answer. So negative 4 to the third power is negative 64. Now, this looks the same, but our negative sign is on the outside of the parentheses. that means it is not part of our base. It is separate, okay? So if you don't have parentheses, or if the negative is inside of the parentheses, that negative is part of your base. If the negative is outside of the parentheses, it's not part of the base. So in this case, I have negative 5 times 5 times 5 times 5. Okay? So now I'm going to multiply. 5 times 5 is 25. 5 times 5 is 25. I'm going to bring down my parentheses and bring down my negative. 25 times 25 is 625. And I bring down my negative. So this is a negative 625. When the negative is outside of the parentheses, it stays out of the way and moves into our answer. Now, let us look at a few fraction examples. Okay, so part of this is remembering how to multiply fractions. So we have 2/3 to the second power, and that means 2 over 3 times 2 over 3. I'm not going to do an in-depth review of multiplying fractions. You can watch my multiplying rational numbers video if you need a review. But we're going to multiply numerators and denominators. So 2 times 2 is 4, and 3 times 3 is 9. Our other example has a negative inside the parentheses, so the negative is part of our base and will be included in every time we rewrite. And as before, if it helps you keep everything more organized, you may put each of these numbers inside of parentheses. So 4 times 4 is 16. 16 times 4 is 64. 5 times 5 is 25. Times another 5 is 125. A negative times a negative is a positive. A positive times a negative is a negative. So negative 4/5 to the third power is negative 64 over 25. And for our final examples, let us look at a few decimals. Okay, so let's start here. We have 0.4 squared, so that's 0.4 times 0.4. Again, if you would like a review of multiplying decimals, you can view my multiplying rational numbers video. 0.4 times 0.4. I know 4 times 4 is 16. I have 1, 2 numbers behind decimal points, so I have 1, 2 in my answer, and bring down my 0. Okay, now negative 1.1 to the third power. My negative is inside of the parentheses, so it's part of my base. So I have negative 1.1 times negative 1.1 times negative 1.1. So 1.1 times 1.1 is 1.21. A negative times a negative is a positive, so we'll leave this alone, times negative 1.1. So 1.21 times 1.1 is 1.331. A positive times a negative is a negative. And for our final example, we have negative 2.41 to the fourth power. Okay, the 4 is outside, is my exponent, but the negative is outside of the parentheses. That means it's not part of my base. So I'm going to leave it outside and not multiply it 4 times. Okay, so I have 2.41 times 2.41, which is 5.8081. when I multiply 5.8081 times itself, I get 33.73405.02561. So I'm going to round that to 2 decimal places, so that will be 33.73, and I'm going to bring down my negative into my answer. And that is how we multiply using exponents, how we solve exponents with different rational bases. Thank you for joining me on this Math with Miss V video.